Hi everyone, this is Amit Priyadarshi and I'm currently working with Synchron. I'm part of a practice called Payments and as part of this practice group, I currently manage information management practice. I'm a core data guy, having a lot of rich experience working with data and its implementation. And I play the role of a data architect come solution architect with any data project of delivery. Today I'm going to talk about one concept of data implementation which is picking up very well these days. It's called data fabric. I won't talk much about the theoretical aspect of data fabric. You will find a lot of information on Udemy and YouTube courses. But my goal of this particular session is to explain one actual real-time implementation which I have been part of so that you understand exactly how this is implemented and how what comprises of data fabric. So this example which I'm going to talk about is about one very large telco player based in India with whom I worked some time back. They had a very large data warehouse, something around size of 50 terabyte. Now 50 terabyte seems very less these days when we talk about big database storage, which in terms of petabytes. But trust me, 50 terabyte for managing is still a big thing when you have to deal with large complex schema and data coming from different 50 plus systems and all those actually. The data warehouse which they had was used for different purposes of telco needs. The customer relationship management, the billing system, the CDR management, etc. The lot of analytical reporting and regulatory reporting also used to happen from there, and this is kind of a heart of the entire IT system. Now, this data warehouse was being managed by Teradata, where the appliances were used, and it used to be a costly affair. The lot of money used to go on yearly basis for the storage and the processing power. Now, this company was in 2G earlier, and they had to directly go to the 4G network. And when they did the estimation, the initial primary estimation of the storage they would need to have in 4G world, then it came out like they will have to store the data now more than 1 petabyte per year. So going from 50 terabyte to 1 petabyte actually means more than 20 times of data storage. That actually means that their cost of running this data warehouse will increase 20 folds, 20 times. Now this is not easy thing. A lot of company money goes in managing the IT cost, and something of this scale where 20 times increment has to happen. This will never work actually in any scenario. Now, this was the perfect case of big data based implementation situations where cheap commodity hardware concept could be dealt with and then brought in here into this picture. Now, anywhere bringing a new infrastructure and new architecture completely from scratch is not an easy task. There's a lot of investment, a lot of time already put into the existing implementation. Um, there's a lot of effort goes into stabilizing the existing infrastructure and the architecture and the design, and that cannot be simply moved to a new platform altogether. So the best way normally goes for any big data based implementation is that you go into hybrid mode, like where your existing investments are safe, but at the same time you also bring the new architecture in place, and old and new architecture both work together hand to hand. So now in the case of this telco customer, the new platform will look like you have the Teradata based existing platform which will carry the existing data set mainly related with the billing system and then old CDR data, and the new platform which comprises of a big data cheap commodity hardware based at Apache or Hortonworks based Hadoop system will carry the new set of XDR data, which is related to 4G. Now, these two, data layers can work independently of each other, but they need to integrate a lot with each other as well. There's a lot of aggregation that has to happen at the CDR level, at the customer level, at the product level, and those needs to be captured and shown to business users and reporting and analytics team. So, in simple words, that when we bring the new platform into the system and the existing is also existing, the hybrid mode will mean that a lot of integration is happening and a lot of data movement is happening, and then even the reporting has to happen at both the system. So now consider the case of what happens during the reporting time. So let's say a report developer or a report analyst needs to get data from both the system for generating one report. Few data elements are coming from Teradata, which is the existing platform. Few data set has to come from the big data side. And consider the complexity of these two technical components. You know that it's not easy to get it in one single data view. It's always very difficult when you have to get the data from one system, then another system, then merge it and then give it to the downstream users or application, and this is going to take time. You can't build a typical regular reporting environment where at the same time both data comes from both the sides. It's going to be very difficult actually. Now this is where the concept of data fabric come into picture, which says that data which are available at different disparate system needs to be centralized for central reporting and analytics purpose. So in this particular case, when some data elements are sitting at Teradata, some elements are sitting in big data, we need to have a common layer which centralize, which consolidate data on the fly from these two systems and present the data element to the user or reports in a consolidated manner. There used to be concept called data virtualization, which is one of the implementation of data fabric. These are tools like TED, JBoss, Denodo, which are in use, which actually give you a centralized metadata layer, which combines the entities and attributes from these two systems and then give you a consolidated layer through which you can do reporting and analytics. So the way it's gonna work is that you have a layer for Denodo, for example, where you will publish the data elements from Teradata as well as HDFS or Hive, and then create a common view, and then that view is published to the end user. The end user is actually using that common view into the reports and analytics, and this particular tool, Denodo for example, on the fly it goes to these two systems, handle all the technical complexity of converting the query, the SQL query into the actual physical query specific to Teradata or HDFS, get the data and give it back to the user on the fly. For making this process improvement, there's a concept of data pinning as well, where the common elements are stored at the Denodo server only. Now, Denodo is just a physical implementation of this concept, but in short, data fabric is all about consolidating your data, which is there at multiple different location or technological infrastructure, and give it a consolidated view to users or downstream application for its own needs and purpose. So in short, data fabric is an architectural pattern which integrates data available at multiple different systems, which might be totally different than each other, and it absorbs the technical complexity in itself and give a consolidated logical layer to end user, who could be reports developer or analyst for doing their purpose. I hope that this example you will be able to understand how data fabric is implemented in actual real world. Thank you very much.